About 10 years ago, a colleague and I realized that aquaculture could happen in rural communities in Newfoundland if we could go on land. The problem is that it costs a lot of money to pump the water to land. So the idea we came up with was using wave energy to drive a pump to pump water on land for aquaculture. We knew that in this area there were lots of big waves, the resource was sufficient, but the trick was to figure out how to pump the water. In order to develop the wave pump, one of the first steps was to find a site, measure the conditions at the site, like the wave heights, bathymetry, and so on. We ended up in Lord's Cove on the south coast of the Burin Peninsula. The site at Lord's Cove has worked out really well for us. With the help of the community, we renovated the retired fish plant, installed all the instrumentation necessary to start to measure the waves. From that data, we've designed, built, and tested a scale model of the wave pump at the wave tank at NRC in St. John's. At the same time, we installed and commissioned a land-based aquaculture farm that we're using electric pumping with. This farm has both salmon as the main produced species, but we're taking the wastewater from that salmon and feeding it by gravity into other tanks where we're using filter feeders and sediment feeders to actually clean the water before it goes back to the ocean. In essence, what we're doing is we're maximizing the conversion of feed into saleable product. One of the offshoots of this research is we've ended up developing a wave energy test facility here in Lord's Cove that we can now make open to other researchers who want to develop equipment or test devices in a harsh North Atlantic environment. We have up to 8 sites licensed under the Navigable Waters Protection Act, and we have all the infrastructure to deploy, recover, and measure things that are going on. We've had several companies interested in testing devices or instrumentation, and the college now is ready to enter into public-private partnerships to get that done. The work we have done on the wave-driven pump has led us to realize other uses for this technology. The same technology we're using to pump water to aquaculture sites may also lead us to developing an inexpensive, eco-friendly, and sustainable way to generate electricity. Through the Wave Energy Research Center, College of the North Atlantic is well positioned to be a major player in the research needed to further the aquaculture efforts in Canada and around the world. We are going to expand on these discoveries and apply the knowledge to other endeavors.